In this video, I'll show you how to reflect the quadratic function relative to the x-axis. The question asks, use transformations to graph y is equal to negative 3 x squared and y is equal to negative 0.5 x squared. We learned in a previous video that this number controls whether the parabola will vertically stretch or compress, but we did not discuss what happens when you have a negative value. We'll start off by finding the y-coordinates for this generic quadratic equation, and here they are. Next, I'll find out the y-coordinates for this equation. Negative 3 times negative 3 to the power of 2 is equal to negative 27. Negative 3 times negative 2 to the power of 2 is equal to negative 12. Negative 3 times negative 1 to the power of 2 is equal to negative 3. This is equal to 0. And the same is true for the next three x's. And I'll do the same thing here. Negative 0.5 times negative 3 to the power of 2, and that is equal to 4.5 negative. Then we end up with negative 0.5 times negative 2 to the power of 2, which is equal to negative 2. This one is equal to negative 0.5, 0, negative 0.5, negative 2, and negative 4.5. And in case you need to confirm, you can use your calculator to do that. Next, what I'll do is plot this equation first in black, and I'll plot this one in green and this one in red. So starting with this one, we end up with a parabola that looks like this. So there's the parabola. This represents y is equal to x squared. Now we're going to graph these points, and I know that the intervals for our graph here will not fit the range, but we'll do our best. We'll start off with 0 and 0, 1 and negative 3, 1 and down to negative 3, and the same thing on the opposite side. And that parabola right there represents this column. Before we graph our last column, I just want to point out something. This original parabola is wider than this one. This one is skinnier. And we discovered that when your a value is greater than 1 or less than negative 1, you end up with what we call a vertical stretch. So think of it this way. Imagine I took my finger and I pulled down on this original parabola downwards. It would eventually get skinnier and skinnier. And that's what happened here, a vertical stretch. So let's move on to the red now. So we'll start off with 0 and 0, and 1 and negative 0.5. So 1 and negative 0.5 is right here. And the same thing here, it's like a mirror. 2 and negative 2. Connecting these, I end up with a parabola that is wider than our original in black. And that right there is called a vertical compression. Pretend that I took my finger and I compressed this vertex point upwards. It would eventually make this fatter. The take-home message here is that both of these negatives cause our original parabola, which has an a value that is positive 1, to flip. Essentially, these are a reflection of what the parabola would be if it were positive. Therefore, to conclude, a negative a coefficient, this is our a coefficient, will cause a reflection in the parabola. And so there you have it. That is how to reflect the quadratic function relative to the x-axis. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.